Hey everyone, Mr. Planetsec here. So I'm going to try something new out this year that I haven't done before. What I'm going to do is, instead of giving you guys some traditional homework, I'm going to create little videos for you to watch, sort of to do our lecture part at home. And then when we come to class, I'm going to have you do sort of like your quote-unquote traditional homework, where I'm here, where you can ask questions and work through problems with me in the room instead of trying to do some of those things on your own. We'll give it a try, see how it works at the beginning, and see if we need to make some modifications along the way. Um, Definitely different than what you're used to, but we'll see how it goes. One thing you are going to need is you're going to need a place to be able to watch videos. I'm going to post them on YouTube, so you can either watch them at home, or you can watch them on your computer, or you can watch them in the library because you have access to YouTube in the library. Or if you have a smartphone or an iPod or whatever, you should be able to watch it there too. So let's give it a try, see how it goes. Today's first video is about significant digits. So we're going to go into identifying why do we have to use significant digits, how do we tell what significant digits are in a number, or how many significant digits are in a number, and then do some calculations. Okay, so why do we have to worry about significant digits? Contrary to what you may believe, or what popular belief is, it's not to make your life a living hell, although some of you may feel that way. But it comes from the fact that when we are measuring things, there's a certain degree of uncertainty that goes with all of our measurements, right? For example, let's take a look at this graduated cylinder. There's a volume of liquid in this graduated cylinder. I take a look at my graduated cylinder and I see, okay, there's the 6 line, there's the 7 line. I count up all the little dashes in between and I find that there are 10 dashes, or 6 and 7 has been split into 10 equal segments. So I find my meniscus, notice close cross section here, right? I find the bottom of my meniscus and I see for sure that the level of this liquid, or the volume of this liquid, is greater than 6.2 milliliters but less than 6.3 milliliters. So when I'm recording my measurement, I write down, okay, 6.2. Okay? But then remember that proper measurement technique says, all right, I have to now make a guess about exactly I have to make a guess about exactly where this level or volume of the liquid is in between 6.2 and 6.3. And remember, it only goes one place past what you know for sure. So I take a look at this little dotted line here and I look and I think, okay, it's about 30% of the way between 6.2 and 6.3, or 3/10 of the way. So I'm going to say for sure I know the volume of that liquid is 6.2, but then I'm going to say it's 6.23 milliliters. Okay? Now, is that the exact volume of the liquid? Who knows? There's always some degree of uncertainty in every measurement that we take. If we're going to take a measurement that already has uncertainty and then perform another calculation or make an assumption or try and predict something about something else using this measurement, if it already has uncertainty, we have to limit some of that uncertainty or take it into account when we're making conclusions based off of that number. So let's get to the nitty-gritty. I know that all of you have heard this at least once, probably twice, maybe even 3 times. So I'm not going to spend a whole lot of time on it, but I do want to make sure we cover it. Identifying significant digits. Which of these values or which of these numbers in a measurement are significant? So the first rule is easy, right? Any non-zero digit is going to be significant. If I write down 1, 2, 3, 4, 5, 6, 7, 8, or 9, it is a significant digit. The second rule is easy too. Zeros that are sandwiched between 2 non-zero digits, right? So we're talking about, if I write a measurement that looks like this, 606 centimeters. Would I measure 606 centimeters? Probably not, but whatever. So anyway, that 0 in between the 2 non-zero digits, significant. So this would have 3 significant digits. Okay? And it doesn't matter how many zeros are sandwiched in between those 2 non-zero digits. All of them are significant. So 6, 0, 0, 0, 6 meters. Would I measure 60,006 meters? Probably not, but whatever. Here, because these zeros are sandwiched between 2 non-zeros, this measurement is going to have 5 significant digits. The rest of it, or the last 2 rules, deal with zeros, and it deals with zeros at the beginning and zeros at the end. But what I'm going to tell you right now isn't necessarily what is going to correlate on the screen, but let's start with this, okay? If a decimal point is present, so let's take a measurement that looks like this, 6.2570. If there's a decimal point present, zeros at the end are significant. If there's a decimal point present, zeros at the end are significant. So this number, or this measurement here, let's say this is, I don't know, milliliters. This measurement here, 1, 2, 3, 4 non-zeros, and a 0 that's at the end of a number that has a decimal point. 5 significant digits. Okay? If the number has a decimal point, 0.425 meters, which is a reasonable amount that we might be measuring this year, regardless of whether there's a decimal point or not, zeros at the beginning, not significant. Any zero that you write at the beginning of the number to hold a place or whatever it is, not significant. So this, only 3 significant digits. And it doesn't matter how many zeros you have in there. 0.0425 meters. Any zeros at the beginning of a measurement that you write, not significant. So once again, this number, only 3 significant digits. Okay? The last rule being, if there is not, let's see if this messes me up again, if there does not have a decimal point, so let's say something like this, 6,500 kilometers. If there is no decimal point, zeros not significant. So this number would have 1, 2 because of the non-zeros, but this is not significant, this is not significant, this measurement only has 2 significant digits. So decimal point present, right? If there's a decimal point there, zeros at the end are significant, zeros at the beginning not significant. If there is no decimal point, zeros at the end not significant. If you had Mr. Horwath for physical science, he may have taught you a little mnemonic device about the Atlantic and the Pacific. Hey, whatever works for you. Okay. So, last rule, scientific notation. If we write a number in scientific notation, anything that we write down is significant. Remember that scientific notation is supposed to contain a number between 1 and 9.9999999, etc., 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 right? So here, 4.27 times 10 to the 4th meters, this would have 3 significant digits. 4.270 times 10 to the 4th meters, right? 1, 2, 3, 4 significant digits. 0.467 times 10 to the minus 14th meters shouldn't be written in scientific notation this way. You shouldn't have a 0.467, right? 4.67 times 10 to the minus 15th meters, 3 significant digits. So you always have a fallback plan. If you're not sure how many significant digits you're supposed to have, you can always write it in scientific notation. Practice time. Up on the screen, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 measurements. Why don't you hit pause wherever you're watching this thing, take a couple of seconds, see if you can identify the number of significant digits there, and I'll be back. Well, hit pause, and then when you're ready, hit play, and the answers will appear. Hopefully we did okay. If you have any questions, ask them in class tomorrow.